Okay, so in this last video, I want to talk about a few miscellaneous features about grep and regular expressions. The first one is going to be these things called character sets, and the second thing I'm going to introduce is this thing called back references, but we'll get there in a second. So suppose for this example, instead of working with cats, I'm going to work with passwords. So I have a file of passwords. Some of them might be mine, some of them might not be, who knows. What I want to do is I want to search this passwords file for some passwords that have a specific format in them. So suppose, for example, I wanted to see if there are any passwords in here that had the characters A or B or C. So with what we've known so far, you can go ahead and write something like that. Grep A or B or C, and then search in passwords.txt. So I found all the A's, B's, C's in this file. Great. Now, it gets a little bit more tedious if you want to write a bunch of OR conditions, specifically if you're looking for a single character. So, regular expressions provide this way of creating a character set. The idea is instead of separating a bunch of things by ORs, if you put things in square brackets and then type ABC, it's kind of like enumerating a list of options. What we're writing here is we want one of A, B, or C. And this should give us the exact same result. But it's nice because you can start writing more complex things like A, B, C, D, E, F, G without having to write all those OR symbols. But these things are equivalent to this parenthesis A or B or C. This is just saying some A or B or C or D or E or F or G. So this kind of character set here is for this kind of grouping is for kind of just enumerating one of many options. Now, because it's so common for you to want to look up letters or numbers, they provide special syntax for all letters. So you don't have to write out these square brackets A, B, C all the way to Z. Instead, what you can use is the shorthand syntax, A dash Z. This is going to find you all letters. This is not, in some sense I'll mention, this is not anything fancy. It's not going to be able to work in all contexts. You should really think about this as just shorthand specifically for the lowercase letters A to Z. You just write this A-Z inside these square brackets, and regular expressions interpret that as any valid lowercase letter. Similarly, you could do this with uppercase letters. So it has another special case for uppercase letters. And it also has special cases for numbers. So you could say 0 to 9. And one thing that you sometimes see is you sometimes see these things together. You might see A dash lowercase A to Z, uppercase A to Z, 0 to 9, which will match any of those things. But you should really just think about that A dash Z as being expanded into A, B, C, D. You sometimes will see things like this. This gets a little bit weird. Don't worry, these things get weirder. When you have these square brackets, regardless if you're using a special 0-9 syntax or just writing out ABC, sometimes you want to be able to find something that doesn't match this. So maybe you want to find all things that aren't numbers. The way you negate one of these character sets is you use this up arrow. Now, this is really confusing for a couple of reasons. One, because wasn't this supposed to be the syntax for the beginning of a line? It totally is. They use it in multiple contexts. So this is really, really strange that they use this character to also mean not. So this only means this in this context of inside square brackets. So if you have square brackets with this caret, this up arrow at the first thing, this means a not match of one of the values in this character set. Now, except for this up caret, it turns out that everything that's going to be inside these square brackets is actually treated literally. So there's no special regex characters anymore. So if you search for $, this is searching for all things that are literally not a period or literally not a $sign. We don't get inside these square brackets the nice regular expression language anymore. So that's one of the weird things too about these square brackets is first, it uses that up caret to say not, and then it treats all special regular expression characters as just regular characters, which is just super, super weird. I thought I should just mention this now in case you ran into it. but you won't see it too often. You do see this not thing. Very common for you to find like something that's not a number. So one other nice thing about these character sets is that you can compose them with everything we've done before. So for example, if you're looking for one or more numbers, you could use this numbers character set and then plus. This is going to find you a series of one or more numbers. Same thing with star, same thing with question mark. You can even get fancier if you want to say a slightly different way of writing this out. You could have said 0 to 9 or A to Z, but then we kind of get to this problem before of what those square brackets were trying to solve. But there's that. Now, one thing that's sometimes useful is the ability to search for a specific number of things. So what if I'm looking for exactly 2 numbers? So I could write out the 0 to 9 twice. I can't quite use plus because that's 1 or more. I can't use question mark or star. So it turns out there's another way of doing this where you use these curly brackets and you put a number in there. So this is saying, find me 2 digits between 0 and 9. So it matches these. This curly bracket syntax for specifying numbers is actually really expressive. You can also put upper and lower bounds. So for example, if you say, just put a comma there, this is finding you at most 2 numbers. And notice that it actually highlights 1, 2, 3 in here, not because I lied to you, this is doing the right thing. It first matches 1, 2, and it says, oh, that's a match. And then it moved on to finding another number, part of its different match of at most 2 numbers. You can always, you can also lower bound these. So you could say anywhere between 1 and 2. So if you wanted to get fancy, you could say anywhere between like 2 and 3. Just like you can infer the lower bound, you can upper bound. So say at least 2. Very, very fun. One thing that's a bit weird, or sometimes not, you have to get used to, is that both of these numbers are inclusive. So when you're saying between 2 and 3, you're saying greater than or equal to 2 and less than or equal to 3. So these ranges are going to be included. That's kind of a lot of these things that we've seen. So we've seen a lot of syntax. Whoops. I meant to this slide up here. Sorry about that. I closed this. So we've just seen a lot of this square bracket syntax, where this square bracket defines a character set and it has like these predefined ones, A to Z, 0 to 9. It's not necessarily going to work in other contexts. Those are the only ones that are guaranteed to be defined. And we use that up arrow to negate. But one thing that's kind of tricky about these, we've spent a lot of this time talking about a bunch of syntax. And the syntax is weird the first time you see it, I promise you. What's really important is being able to do the process here of being able to try to figure out, you're trying to search for all passwords that contain at least 2 numbers and figure out how to phrase that in terms of the tools regular expression provides. Counting, saying character sets or ors or at least 1 or at most 2 or something like that. And then looking back to the glossaries and be like, okay, how do I actually write that pattern? And doing this in an iterative process where you have a small test file open and you're making sure it's printing out the things that you want. Those are the most important things. So far in regular expressions, we saw the basics of using things like dot to be a wildcard. We saw how to use 1 or more with plus, 0 or more with star, 0 or 1 with question mark. We also saw how to use that or command and put parentheses around them. And we also use these square brackets to define character sets. The last kind of great feature about regular expressions that I want to show you, and it's going to be a bit weird, is this thing called a back reference. So for example, what if I wanted to match the string like ab, but not, sorry, I didn't mean to press enter, but I don't want to match abba. So what if I want to find these strings that have this kind of repeated structure? So like the first 2 characters and the last 2 characters match. So I'm going to try this. I'm going to try ab. I'm going to do this little echo syntax to kind of remind you that you can always test this out quickly using echo. I'm going to pipe this into grep-e. And then, okay, let's just assume they're all 4 characters long. I want where the first 2 characters match the second 2 characters. So You might know that right now it's not going to work to just search these things because it's not going to work for ABBA since, or it matched ABBA, but I don't want ABBA. I want exactly ab. So things that match together, those two repeated things. So you might be wondering, well, okay, if I did 4 dots, that's not going to quite work because that's going to allow any characters. There's no necessary repetition. You might be wondering, can I use this like ... plus, but that's still going to find it because this pattern is just defining this kind of ... anything, and we're saying more than one of them. I think you could try, maybe if you even just tried this 2 thing, that still doesn't get you anything because when you're saying I want 2 dots, there's no requirement that the actual strings matched there are the same. It's just saying use the pattern ... once and then use the pattern ... again. This is the power where we need something like backreference to say, hey, only match a string that actually was used in the match earlier. Let me show you this first, and then I'll explain what it's doing. Notice here, it didn't print any output because ABBA did not match. But if I do ab, it does. So what does this just do? So the first part is nothing new, this parenthesis ... We're just putting a weird set of parentheses around things, and it's just saying match 2 characters. This \1 is referring to what were the actual characters matched in the first thing that had parentheses. So we look at our regex, we find where our parentheses are. So it's essentially looking, one is talking about these parentheses and saying what characters in the input string actually match this thing. Use that same set of characters again, only allow those. So that's why it matches ab, but not ABBA, because the string that matched this ... for ABBA was AB. And this \1 is then going to refer to, oh, it has to be another AB. But because there was BA, it doesn't work, it doesn't match, so the whole thing matches. This back reference is precisely a way of saying, find me something that we matched earlier. These things can get more and more complex. Why is it \1? Well, it allows for multiple groups. So when you put something in parentheses, you're defining a group. And so this is saying, please match the first group. You can make these more complex. So maybe I put another group, and then I put a \2 that refers to the second group. This is not going to match because I asked for 4 characters, but this is going to be matching a string. Oh, I thought I muted that. This is going to be matching a string like ABCD, ABCD. Because it uses AB for the first 2 dots. Then it matches CD to the second 2 dots. Then when this \1, it's like, oh, what did we match for the first group? Oh, we matched AB. So we have to check if there's AB here in the next characters in the string. And then the last one was CD. Every pattern, the ones with backreferences and ones without, they're all like consuming part of the input. As you're running through the input, you're like trying to say like, oh, I'm going to grab this character because it matches this part of the pattern and move on. And so this backreferences allows you a very powerful way of actually going about kind of explaining what, using an earlier part of the input later on, saying I want to match this thing specifically. So you see these backreferences quite commonly when we have structure in our input. And I want to introduce that now because this tool is going to become really powerful next week when we talk about sed and replacing text, where maybe you want to extract part of someone's email and you'll say, oh, put the email part in parentheses so that I can use a back reference later to get it back out. But we'll practice with this a little bit now, and then we'll see all this regular expression stuff again. And as a reminder, this regular expression stuff is kind of weird the first time you see it. It's a really weird syntax for a lot of non-intuitive ideas. So I do recommend that you start this assignment a little early so you get to practice these things. You can come to office hours, post on the message board if you get stuck on something. It is very weird the first time you come up with these regular expressions. They're not always the most. That's all I have for today. That's all I wanted to talk about. So I will hopefully see you all in class this week.